Alright, so now that we've achieved our main goal, which was to solve right triangles, we're gonna do today some trig applications. So we're gonna begin by taking some notes on angles of elevation and depression, and then we're gonna do some examples. So here's the angle of elevation, here's the angle of depression, and I've sketched it in pictures and diagrams. Basically, an angle of elevation is when you are looking at an object that's above you, and an angle of depression, you can think about it as looking at an object that it's below you. So for example, maybe you're on a boat and then you're looking underwater and there might be a fish. You can create an angle here. Or maybe you're laying down by a tree and you see a bird and you decide to go look at it. You can also create an angle like that. So now let's do some examples. And here, I want you to describe each angle as it relates to the object in the diagram. So label angle 1, what is it? Is it angle of depression, or is it an angle of elevation? The same for angle 2, angle 3, and angle 4. So go ahead, do this quickly, put freeze, and then I'll write down the answers. Here, angle 1 is an angle of elevation. You can see this person looking above at a tree. So the angle that's being created is an angle of elevation. Angle 2 is an angle of depression. So think about maybe like an apple falling down, and here it's creating this angle below. Angle 3 is angle of elevation. So think about maybe climbing the tree and then looking up at this bird right there. And angle 4 is an angle of depression. So here, angle 4, think about the bird's eyesight. It's looking down. Now let's go ahead and check out some application problems. So example 1, an engineer stands 50 feet away from a building and sights the top with a device on a tripod. The angle of elevation is 50 degrees. How tall is the building? Let's make sense out of this couple of sentences by drawing a picture. So here we have an engineer, and we're given that he stands 50 feet away from a building. So then this distance is 50 feet. And now he has a device, so let's say maybe he has a tripod or whatever. He has a little device here, and now he's looking above. And they're saying that the angle of elevation is 50 degrees. And remember, elevation, we're looking above, right? So that's you and you're looking above. Here's the angle of elevation. So here, this angle will be 50 degrees. Now we're trying to find how tall the building is, which means that this height, that is the unknown that we're trying to solve for. Now let's go ahead and label this triangle in terms of the 50 degrees. So 50 degrees is the angle of reference, and the side that's opposite of 50 degrees, that's always called the opposite side. Here, the lines here, these perpendicular lines create the 90-degree angle. So the distance that's across 90 degrees, that's going to be the hypotenuse, but I don't have any information about the hypotenuse, so I'm just going to leave it blank, which leaves this 50 feet to be the adjacent side. Now let's use this graphic organizer to strategize what to do next. So what information do we know? Well, we know the angle being 50 degrees. And we also know the value of the adjacent side. So the adjacent side, which is equal to 50 feet. Now, what are we trying to find? Well, we're trying to find the opposite side. That's the unknown. That's x. So if we write out so katoa, we're going to use these two lengths. We have to use the adjacent and the opposite. And the adjacent and opposite, that one screams to us with tangent. Tangent uses opposite over adjacent. So here we're going to do tangent of the angle of reference, which is 50 degrees. And tangent by definition is the ratio of opposite over adjacent, so we're going to get x and divide it by 50 feet. So we get x over 50, and now we can solve for x. So here I'm going to split this equation into two. On my left hand side I have tangent of 50, on my right hand side I have x over 50. So tangent of 50 I'm going to divide it by 1, and now I can cross multiply. So 1 times x, that's going to give me x. And then 50 times tangent of 50, that is going to give me 50 tangent of 50 degrees. Two lengths, we have to use the adjacent and the opposite, and that screams to us to use tangent, TOA, because tangent makes use of the opposite side and the adjacent. So let's go ahead and set that up. So we're going to get tangent of our angle of reference, which is 50 degrees, and that's going to equal the ratio of opposite over adjacent. So the opposite is x over the adjacent, which is 50 feet. And now we can divide a tangent of 50 by 1, and we have a proportion now. When we have a proportion, we can apply the cross multiplication, so we can get 50 times tangent of 50, and that's going to equal 1 multiplied by x, so we get 1 times x. And now we're in good hands because we can solve this equation. On the left hand side we just get 50 tan of 50, and on the right hand side 1 times x is x. So we can simplify the left hand side by inputting this in the calculator, and I get an approximation. X is approximately equal to 59.59. For these problems, round to the nearest hundredth, so to 2 decimal places, and we should include the units, so 59.59 feet. Okay, so let's try another application problem. Let's do example 2 now. If a plane that is cruising at an altitude of 30,000 feet wants to land at a bush field, it must begin its descent so that the angle of depression to the airport is 7 degrees. What is the horizontal distance from where the plane begins its descent to where it lands at the bush field? Again, just like in the previous problem, we're going to make sense out of it by drawing a picture. So here they're telling us that we have an altitude of 30,000 feet. That means that we have a height here of 30,000, and here we have that plane, right? That's the altitude of the plane, or it looks like a B, but that's a plane. And then the plane wants to land on the field here, and in order to land, it must descend so that the angle of depression to the airport is 7 degrees. So we have an angle of descent that's going to be 7 degrees. What is the horizontal distance from where the plane begins its descent to where it lands on the bush field? So we're looking for this horizontal distance right here. So let's call it x. Let's begin to label our triangle in reference to 7 degrees, because this is the angle of reference. And remember, where the two perpendicular lines meet, that's going to create that 90-degree angle. So the length that's across 7 degrees, that's going to be called the opposite side. And the length that's across 90 degrees, that's called our hypotenuse, but here we don't have anything for the height, so we're not going to go and bother to write that down. So that leaves this length to be called the adjacent. Let's record this on our graphic organizer. So what information do we know? Well, we know the value of the adjacent side, so let's write adjacent, that's what we know, it equals 30,000 feet. And then we also know the angle of depression, or we can just write the angle, which is 7 degrees. What do we want? Well, we want to solve the unknown variable x, and that happens to be called the opposite side in reference to 7 degrees. So here we're trying to solve for the opposite, and we can write SOHCAHTOA, and it's going to take us about a couple of seconds to realize that here we're going to have to use tangent again, because we have opposite and adjacent. Opposite and adjacent are what's needed to calculate the tangent. Let's set this up. So we're going to get tangent of 7 degrees, and that's going to equal the ratio of opposite over adjacent. So the opposite is x, the adjacent is 30,000. I'm going to divide tangent of 7 degrees by 1, and we can do the cross multiplication. So we can do 30,000 tan 7, and that's going to equal 1 times x. And now all we need to do is just simplify the left hand side. So x here is approximately equal to 3,683.54 feet. So go ahead and finish the rest of the assignment, and I'll see you in the next lesson.